Alright folks, put your hand up if you want to hear about ASCII. I can't see any of you, but I know your hands are up. Okay, so before we begin, let's just have a look at the arrangements from the SQA about what we actually need to know, and in particular this part here. Describe extended ASCII code. Remember 8-bit, okay, that will be coming up soon, used to represent characters. And at this point, I'm assuming that you have good knowledge of how to convert to and from binary numbers into decimal. And if we were to have a little go at this number here, you should be able to convert this. Every time there's a 1, we take that number from above. So we end up with 64 plus 16 plus 1, which gives us 81. Okay. If you are not aware of how to do this, then you need to go back to lesson 1, which is about binary numbers. Okay, so if our learning intention is I can describe extended ASCII code 8-bit used to represent characters, a success criteria would be I can explain and give an example of an ASCII character. I can describe how many bytes are needed to store a single character of text, and I can describe the term character set and explain why different character sets are needed. So these days we save so much information on our computer, and that can be in the form of audio or video or graphics, or in the simplest form text, and that's the one that we're concentrating on today. Back in the day, each computer would have its own way of saving text as binary. Now, if one computer had saved text in a specific format using binary and then sent that information as text to another computer that used a different format of binary, then the message wouldn't make sense. So people realised this was an issue, and a group of people got together and came up with the idea of ASCII. Now, this was developed in America, which is what the A stands for, American. It's a standard, which means it can be used on any device, and it's code made of binary. Now the two I's stand for information interchange, and this basically means that it's data that can be passed from one computer to another computer. Now this image is a little small, so you might find it a wee bit difficult to see all the information. But this is a character set. Okay, it's a set of characters with the assigned numbers. Now this is the ASCII character set. So what you can do is you can see a letter. So on the right hand side you can see the small letters for the alphabet starting with A. And you can see here that that has the number 97 assigned to it. I should also say at this moment, forget about hex and oct. The two columns which are in the middle of the character and the decimal number. It's just that this table has inserted that, so forget about that. So this is the standard unique code that was internationally agreed on. So 97 is the decimal number for A. So every time you type the character A or send the character A, it's actually 97, but not 97 as we would see it, 97 in binary. So every time A is pressed, the computer converts that A into binary, and that is what is either saved or transmitted. And this is the same for all of the characters that you can see there. You can see T has the decimal number of 116. So when you type T, it is actually 116 in binary, which is 011101010. So if you were to actually send a text message which had the word at in it, it would actually be sent or saved as 011000101110100. Now, how many bits is this used? It's used 16 bits. If you were to count all the ones and zeros, it's 16 bits. So the word at would require 16 bits, or because there are 8 bits in a byte, we would say that at takes 2 bytes of storage in order to save this. So you should see on this character set, we have the lowercase characters, we have uppercase characters, we have symbols such as the @ sign, hashtag, equals, question mark. We also have the numbers, which funnily enough don't follow the decimal numbers for us. So 0 is actually decimal number 48, which you would then convert into binary. 9 is 57, which again you would convert into binary. What is not shown in here, because this is not the full character set, is the fact that we have control characters also on here. So if you think about your keyboard, we have things like shift, command, control, function button, escape. These are all what's known as control characters. And what that means is when you are to press them on your keyboard, they don't actually print anything on the screen, just like a G or an H would. The control character is also known as a non-printable character. Now, if you have a look up at number 32 in the ASCII table, you'll see that that is for space. Now, even a space needs to have a binary number associated with it. So every time you press space, it's actually 32. In binary, that would be 00100000. Again, this would take up 8 bits of storage space in memory in order to save this. So the original ASCII actually only used 7 bits to store every character. But then people kind of ran out of characters, okay, because you could only represent 128 different characters with 7 bits. By using an extra bit, this resulted in us being able to represent 256 characters. And this was known as extended ASCII. So the extended ASCII character set allows us to have 256 characters, which is way more enough in order to have our uppercase, our lowercase, our numbers, our non-printable characters, our symbols. But is it enough in order to have things like Arabic or Greek? 256 characters? Probably not. Even things like emojis, there wouldn't be enough space in that character set in order to save all the things that we like to use when we're sending text messages or emails. So, is 8-bit characters enough? Possibly not for that type of thing. If you want to investigate a little more about this, you can do your own little bit of research, or you can wait until higher, where we learn a bit more about different character sets. Okay, so we're now at the stage where we return to our success criteria to see if we can tick off all the things that we should have learnt by the end of this. So I can explain and give an example of an ASCII character. Okay, so hopefully we could do that after this. I can describe how many bytes are needed to store a single character of text. So again, have you got an idea of the number of bytes or bits used to store each character? And I can describe the term character set and explain why different character sets are needed. Again, hopefully you can tick that off. If not, feel free to go back in the presentation in order to tick that one off.